Alright, a problem I might like to be able to do is one that said something like 74 people went to a monster truck show. $676 worth of tickets were sold. Adult tickets cost $10. And youth cost $6 each. How many of each ticket, of each type of ticket, was sold? Okay. Well, let's think about this. If I say I'm going to let x equal adult, y equal youth, and x plus y then would be the total number of people who went, and that was 74. Okay. Now, as far as ticket prices go, I know that 10x plus 6y equals 676. Okay. So now what I can do is I can take this equation up here and solve for one of the variables. Like I could say that y is equal to 74 minus x. And I could replace this y down here. So I'd get 10x plus 6 times 74 minus x, and that equals 676. So now if I do this distribution, I get 10x, and I get 444 minus 6x equals 676. So, well, now what we can do is we can combine like terms. And let's see what we're going to get. Let's see. 10x minus 6x is 4x. And if I subtract 444 from each side, I get 232. Now, 232 divided by 4 gives me x equals 58. Well, and if x equals 58, 74 minus 58 equals 16. So it was 58 adult and 16 youth. Now, another type of problem I would be able to work with is one that has rational exponents. In other words, if I had 1/7 raised to the 1/5 power, and I'm going to raise that all to the -5 power. When I raise an exponent by an exponent, I multiply them together, so that would give me 1/7 raised to the -1 power. Now to write that with a positive exponent, I flip it which gives me 7, and then the exponent is 1. Now the thing with rational exponents to remember is that if I have something like 3 raised to the 1/2 power, that equals the square root of 3. The denominator in the fraction tells me which root I'm taking. Right? If I had 3 to the 1/3 power, I would have the cubed root of 3. And we'll probably revisit this again a little bit later. Now, let's say that we had another problem where f of x was equal to x minus 6 squared. And I asked you to find f of 2 for me. Well, that becomes 2 minus 6 squared, which is negative 4 squared, which is 16. Let's say I asked you to find f of negative 2. Well, that becomes negative 2 minus 6, which is negative 8 squared, and that is 64. Let's say I asked for f of 0. 0 minus 6 squared. Negative 6 squared is 36. Okay. Now, let's say that I told you that f of x equals 25. So what that tells me is that x minus 6 squared equals 25. So what I can do then is take the square root of each side, and I get x minus 6 equals 5, and x minus 6 equals negative 5 from the square root. Up here I add 6 to each side, and I get x equals 11. Down here I add 6 to each side, and I get x equals 1. And that's how we do that problem. Now, again, let's take a look at some graphs. And let's say that I had an axis that looked like this, and I had a graph that looked like this. And I asked you, is this thing a function? And hopefully you would say yes, because it passes the vertical line test. And then if I asked you for the domain and range, you could look at the points on the graph and be able to ascertain what the domain and range were. So, let's remember that the domain are the x values. And we have filled in circles everywhere. So this is x is less than or equal to, or x is greater than or equal to. So as I look at this, the smallest x value is negative 4. So negative 4 is less than or equal to x. And the biggest value is 4 for x. So x is less than or equal to negative 4, and x is less than or equal to 4. Now the range, again, y values, the smallest y value is negative 3, and the biggest y value is 5. So the range is negative 3 is less than or equal to y, less than or equal to 5. Now, how would this change if I had my function and my function looked like this, but I had open circles at the end. Well, for the domain, the x values, instead of being or equal to, it's just negative 3 is less than x, which is less than 3. And for the range, y is greater than negative 2 and y is less than 3. The or equal to has been dropped. Okay. Now, let's say that I gave you a quadratic equation. 2x squared plus, what do I want? Let's go plus 2, and let's go with 5x in the middle. Okay. And let's say that we want to find the zeros of this thing. This is what y is going to equal, and let's let that equal 0. And let's hope that I came up with an equation that's going to have zeros. How could we do this? Let's do quadratic formula. Let's make sure we got zeros. So x would equal negative b plus or minus the square root of b squared minus 4ac. Oh, and this is going to work out. And this is all over 2a, which is equal to 4. So we'd have negative 5 plus or minus the square root. 4 times 2 is 8, times 2 is 16. 5 squared is 25. 25 minus 16 is the square root of 9. Oh, that works out nice. Over 4. So we get negative 5 plus or minus 3 over 4. Okay. So let me see, what's this going to give me? This is going to give me x equals negative 2 or x equals negative 1/2. Okay. So that's one way of finding the zeros. Now another, 2x squared plus 5x plus 2 would be to factor this thing. You could graph it. You could do a table. All those things would work for you. To factor this thing, I take the leading coefficient and the constant and I multiply them together and I get 4. And then I look at this sign right here, and that tells me that I need two numbers that multiply to 4 and add 5. And fortunately, 4 and 1 work. Plus 4x plus 1x plus 2. Okay. So now I can look at the first two groupings, and I have 2x squared plus 4x. I factor a 2x out, and I have x plus 2. Now I look back over here, and I've got nothing in common but a 1. But I've got x plus 2, and then, oh my gosh, would you look at that? Well, stuff my turkey, I've got x plus 2 and x plus 2 right here. I can factor those out, and I get x plus 2, and I get 2x plus 1. All that equals 0. Now from this one I get x equals negative 2, and this one gives me x equals negative 1/2. And those are the answers we got the last time. And I see that this video is getting over 14 minutes, so we'll stop right here and we'll move on to the next video.